Hello everyone, today we are doing complex number problems from IB Math higher level. We're just taking basically past paper problems and going through them. I've not seen this before, so I'm not going to introduce it anymore. We're just going to do the problem. So this is the complex numbers W and Z satisfy these two equations. This is probably going to end up being a kind of simultaneous equation style problem. But I'm going to be careful in the way that we structure this. Each complex number equation that you get generally can be turned into two distinct equations, because in each complex number equation you're going to get a real component and an imaginary component, and both of those can be split off into two separate equations. So two equations here become four. That means we have the capacity here to deal with four unknown values. And that's good because we're kind of looking for four unknown values, right? We're looking for Z and we're looking for W. It says W and Z are in this format, right? So Z is, let's say, A plus BI. W is going to be C plus DI, for example. So that's four unknown values. And we have the ability to set up enough equations to solve for this. However, as a rule of thumb, if there's a way to do it, we want to minimize the number of unknown variables that we're using. And I think this first equation kind of gives us an opportunity to sort of only have two, basically. And I'll show you what I mean by this. So if we do Z over W equals I, one way that I can rearrange this is to say that Z is Wi. So instead of like thinking about these as distinct, I could just go in and say, let's make W A plus BI. And then if we multiply A plus BI by I, that's going to be AI plus BI squared, which is AI minus b, because I squared is -1. And this allows us to basically represent both our complex number equations in terms of the same two variables. And this is going to dramatically cut down on the amount of work we're going to have to do later. If you make four different variables, it's solvable, right? But this is a non-calculated problem, and the math's going to get pretty ridiculous. It's going to be horrible arithmetic. So let's not do that. The other value we have here is W conjugate. W conjugate is going to be A minus BI. So if we come back into this setup here and we start playing around with this next equation, I have erased the working out. You don't want to do that if you're doing this in a test. But I've erased the working out, so that's helpful. A minus BI, that's our W conjugate. 2 times -b plus AI, that is our sort of Z substitution. This is then going to be equal to 4 plus 5i, like this. So if we work through this, we're going to have A minus 2b, and then plus 2a minus bi, and then this is equal to 4 plus 5i, like so. Oh, yeah. Have I failed something? No, I haven't. Panic over. I thought this should be minus 2b because I saw this, but that's not with a complex number. That's not with the imaginary component. So what does this tell us? It tells us that a minus 2b ought to be 4, and it tells us that 2a minus b ought to be 5, because we can always equate our imaginary components, and we can always equate our complex components. So this allows us to set up two equations, like we said at the beginning, where you're splitting things up. And then this is relatively straightforward, I think, to solve. We could double this, so we'll do kind of elimination. Minus 2b equals 4. Nope, I can do basic math, I promise. 8 and... Nope. 4 and 8. And then this is going to be 2a minus b equals 5. And we can just eliminate these by subtracting them. So this, if we subtract this sort of second equation from the first, we're going to get minus 3b, and then this is going to be 3, and then b is minus 1. And then we come back over and we just solve the rest of this. So it's a plus 2 equals 4. That is from this equation. So we're plugging minus 1 in. Negative 2 becomes positive 2. A becomes 2. And so what are w and z in the form of a plus bi? Well, z, if we say b is minus 1, it should be 1 plus 2i. And w ought to be 2 minus I. And those should be our solutions. This is z, this is w. So we're getting from this a relatively straightforward substitution if at the beginning we can make the decision to just have 2 unknown values. If you go for 4 variables, this is going to be a nightmare, but it ends up resolving in kind of a relatively straightforward way. We just get a kind of a normal simultaneous equation problem that we have to deal with. So I hope this is helpful. There are 2 other videos that either will be on the channel or will be uploaded to the channel. They'll be on a playlist, so you can have a look at those.